Now, hey guys, today this is the second episode of the ocean, and I will like to have a later half of this chapter. So, shall we record your memory about the previous lecture? So, what is it about? So, ocean is a very great place where you can get lots of natural resources. So, and we would like to talk about seawater in particular. So actually, seawater contains two main things. Most of them they are solid water, and we have got some solid, which is we call it salt. And indeed, salt is a mixture of different types of salt, and sodium chloride, log is just one of them. Now, we just come up with the way to extract water and salt from the seawater. It is or both methods. We record it as physical method. It's because that you are going to make a separation of the mixture, okay, and water and salt, they get mixed to form seawater again. So this is what I would like to talk about. So recall your memory about how to get the salt. It is by evaporation. And while you from seawater, you want to get water, it is by simple distillation. So both of the methods, we call it as a physical method. Now, so what I would like to show you recall your memory about how to obtain the salt from seawater, physical method, no chemical changes. So we would use evaporation after filtering all those insoluble impurities. So we may either get the direct heating or heating with a steam bath would help. And if you want to consider having crystals, large solid, 晶體, so you may consider crystallization. We have got two ways. If you want to have a smaller crystal, you can do it in a more efficient manner. It's done by cooling a hot concentrated solution. Okay, so but if you want to talk about the slow evaporation of a solution at room temperature, and you will get a larger crystal. So this is what we will stop at that last time. Now, how about water? How can you get water? Once I evaporate the water, if you can have a instrument or experimental setup to collect and condense those vapor or maybe even steam, and we will get distilled water. So this is what we would like to talk about. It is simple distillation. We would like you guys to take a look on the two setup. One is using simple apparatus and quick fit apparatus. To start with, this setup, quick fit apparatus, it seems more sophisticated, but some of them you will know it in Form 1, and both this one and using simple apparatus will make use of the principle of the boiling and condensation of water, because water have a lower boiling point than salt. So simply speaking, you're going to heat it and vaporize it, and you are going to monitor the condensation point using the thermometer, and it is indeed the boiling point of water. And then the steam will pass through the cold area. This is the cooler area, while it's cooled by the running water. We call it condenser. So remember the way of water in, water out, and later on that the tiny liquid will drop through here to form distillate, or we call it distilled water. So this is what we'll talk about quick fit apparatus, or even you are going to use some simple apparatus, and that can also help. So what is meant by simple apparatus? We use a boiling tube and containing seawater as usual, and adding something which will make sure the smooth boiling. We call it anti-bumping granules. And similarly, you have got the thermometer. The bulb of here, it is just next to the outlet of the gas. And by doing so, you can measure the condensation point of the of the steam. But this part we do not have any condenser. Instead, I use iso water for the medium to coat and then condense the steam. So the distilled water or distillate will be found here. So this is what we will stop it at our last lecture, and today we will come to something more complicated. So in case I have got two materials, one is white solid and the other one it is just colorless liquid. After the extraction of both methods, how would you know that as sodium chloride it is found inside the white solid and colorless liquid? How we know that it is water? So this is our topic today, and the second half of this video will talk about some other chemical method to further extract some useful materials from seawater. So let's start. First of all, white solid, is it NaCl? I don't know. So for chemists, we have to think of the method to think of the test, which shows unique observation. Unique means only one would have such observations while the others would not. So for sodium chloride, because of the chemical, it is compound. It comprises of two parts. One is the metal part, we call it sodium ion, and the other one is non-metal part, which is chloride ion. We are going to do the two tests separately. One for testing the metal part, the other one we test for the non-metal part. Now to start with, it is for test for the sodium ions, the metal part. We will use the concept of flame test. Flame test. So underline the term flame test. So this is what you would know the spelling of this term. Now I would like to show you the video about how to do the flame test at laboratory. Now to start with, you are going to clean the end of the nickel wire. Use the nickel wire and dip it into the concentrated hydrochloric acid. And heating in the Bunsen flame is used to clean the wire. Some impurities will be vaporized, and I will show it in the flame color. The flame color will not give you some other special color. By doing so, I know that the wire has been cleaned. What's next is to dip the end of the nickel wire with a solid of copper 2 sulfate crystals, and put it into the blue flame. So what you will see, some special color. You may see the flame color being bluish green, which tells the compound contains copper salts. And indeed, it's not just copper. And you may test, and later on you are going to clean the wire again before you test for some other substances. This time I show sodium compound. Do you see that? It will give you a golden yellow flame, a very special color. And if you use calcium salts, it will give you a brick red flame. And finally, for potassium compound, they will give a light purple flame, what we call it a lilac flame, Lilac. So this is what we talk about the experiment. Now, shall we take a look on the textbook again? So you need to the underlying principle is very simple, because for the metal part, it will give, if I undergo strong heating, they will give some characteristic color. Okay, they will give some characteristic color. So you are going to make use of the color to get matched with the substance you are going to consider. So by doing so, you will identify the metallic element in the compound by the flame color produced. So we call it as flame test. The following procedures you need to memorize. Please memorize these steps, and you will be examining the exam. You will have, first point, the cleaning process. You are going to moisten a clean platinum wire or nickel wire, so you may choose either one, with concentrated hydrochloric acid. So concentrated hydrochloric acid in daily life is mainly used as a metal or maybe rust. Actually, the rust stain remover. So you know that rust paint is something brown, but it is not so water soluble. And now you are going to apply some concentrated hydrochloric acid, and you may remove that. So this is one of the uses of the concentrated hydrochloric acid. So you are going to dip the wire in, and this time it is used to clean the nickel wire or platinum wire. And after cleaning, you are going to dip the salt. You are going to dip the wire into the crushed sample of the salt to be tested. And later on, part 3, you are going to put the salt together with wire and heat it in the blue flame, or we call it non-luminous flame, and observe the color of the flame. So because of the color, the different color of the flame, you are going to memorize the different color. So for sodium chloride, what we are looking for is something golden yellow. Golden yellow. So what is that golden yellow flame? Well, if you walk past the street, you may have got the street lamp, the orange street lamp. So that is the exactly color of this. Why? Do you know why? It's very simple, because that street lamp is indeed a sodium lamp. So we have got that sodium metal, which is vaporized at a very, very low pressure, and this time applied a high voltage on that. So we will give out the very characteristic golden yellow flame. So this we call it the sodium lamp. And if you are going to look for potassium, we'll call that little flame, a light purple flame. And a calcium compound, brick red flame, and copper as bluish green flame. Remember that flame color, they are very characteristics, which means that no other substances they will give exactly the same flame color. So by checking the color of the flame, I will know what elements can be found inside. Okay, so this is what I would like to talk about the flame test. So what is that? So what is the use of the flame test? What other significance do you know about the flame test? Or indeed, we do not think about flame test, but the way you treat the metal compound. So if you see this, this, and this, and this. So what will happen if I want to get mixed of the potassium salt together with sodium salt and calcium salt and finally copper salt together? Well, you may think of something like this. So yes, that's exactly. We are having fireworks. We are having fireworks. So indeed, the fireworks will have their characteristic color, and each bomb that will be produced will have got their own formula of different combinations of salt. And because of the careful design of the bomb inside, they will give you different timing in which those salts will undergo strong heating. But after strong heating, some characteristic light will come out. So you may find, wow, fireworks is indeed an application of heating some metal salts. So you may find that so many different colors of the fireworks. For chemists, we would consider in this chapter, we consider having this test, flame test, to identify the certain of metal parts in the chemical, in the unknown sample. So for further details, we are going to talk about emission in the flame test. If you want to get to know more about this, you may check it on the web by yourself. It is something about extension. Now, for the most others, I would like you guys to take a look on the chat point. To take a look on the questions. Take a look. The diagram below shows a simple test to identify a metal element in a compound. So you are going to have this one as usual that you may see in the picture, and then with a powder sample and this. So give you a flame. What is that test? Name of the test, we call that flame test. Remember the spelling. Why is the platinum wire chosen to carry out the above test? Why use platinum? Why not iron? Why not other salts? Water metal? Is because of platinum being chemically stable, or we will call that chemically inert, very stable, or you will talk about it as a very unreactive. So we talk about the same thing, that does not react with other salts, or even you concentrated hydrochloric acid will not be reacted. Okay, so you use platinum. However, you may know that platinum is rather expensive, so you are going to have some alternatives, some other replacement of other substance, so which can be used instead of platinum. What is that? So this is, sorry about that. So we will use nickel wire. Nickel wire. So how will you spell it? Nickel, L-N-I-C-H-R-O-M-E. So what is nickel actually? Nickel, we will call that a type of alloy, a mixture of metals, which is made up of nickel. So we call it lead. So you may find it in coins. And in other chemicals, what we call it as chromium block. So you may find it in maybe the bathtub or the water tap, the silvery part, or maybe the car bumper. So you might get it some chromium in it. So nickel, it is another material. In order to obtain a good performance of the above test, a non-luminous Bunsen flame is suggested. So briefly describe how to obtain a non-luminous flame in the lab. Something from 1 IS. So I'm sure most of you could still remember how can we produce a blue flame. But to start with, what we need to do is to close the air hole first of all. Step 1. Close the air hole. Of the Bunsen burner. And next, what's next is what? You're going to bring the fire source above the chimney of the Bunsen burner. So you are going to add. You're going to bring a lighted match or the lighted lighter and above the top of the burner, and only by this will we start open the gas tank. Never open the gas tap before you do the other steps. And finally, you will produce a yellow flame. Okay, because the air hole is closed. Then later on, slowly open the air hole to produce a blue flame. So this is what we would like to talk about, the procedures. Do you still remember it seems it's quite long procedures, but this is what you are currently doing in our school lab. So what is the color of the flame? So as said before, it is blue. Remember, blue color. Why we use blue color instead of yellow flame or not luminous flame is because you may find some other flame color just like golden yellow for sodium compound. If you use yellow flame, it may interfere with your result, it will mask your observation. So you better use the blue flame for easy observations. So what will be done first if the concentrated hydrochloric acid accidentally spilled onto the skin? So this is what you may know it is something about safety. Lab safety, what is that? You're going to wash your hands, right? Your skin. To wash the affected area with plenty of running water. So this is what about safety. Dilution first. Never use the alkaline to neutralize the acid. Otherwise, the heat they will come out and they will cause you a secondary chemical burns. So it is for part F. the sample gives a golden yellow flame. So what inference, what conclusion can you find from observations? So it's very simple. The sample contains sodium ions. So what is meant by sodium ions? Sodium ions is something we call it lazy. So it is a charged particles. So if for simplicity, chemists will like to draw something like this to show you sodium ions, Na plus ion. So of course, if you think of something plus, there may be something minus, right? To make it neutral. So what is that? N minus, we call that halide ion or that chloride ion. Halide, it comes from the word halogens. It belongs to the family in group 7 in periodic table. So halides is just the compound form of the halogens. So you may use the silver nitrate test. For chloride ions, we'll give you the chemical formula Cl minus ion is something minus. So you are going to test whether or not the sample contains chloride ions. You are going to use silver nitrate test. So what is silver nitrate test? I need to acidified it. So you may find that acidified silver nitrate solution. So what is a silver nitrate solution in our daily life? Do you use it? Yes. It is mainly used in some medical applications to clear some very bad growth of the skin, or maybe you use it or as a raw materials of making plain mirror. So you know that mirror we have got the reflected surface, right? So it will reflect your image, your object to form an image. So this is I use the silver nitrate to make it. So how will you get the silver nitrate test? First of all, again, you are going to remember the steps. If the sample is a solid, if it's a solid, you're going to dissolve it into distilled water. If not, if it is in seawater sample, for example, seawater sample, so step 1 can be skipped, and you are going to add step 2 directly. Okay, so here we go. I would like to show you the YouTube to talk about the clip. How would you perform the experiment? Let's start. So first of all, yeah, just like this one, you can identify the chloride ions in sample by adding dilute nitric acid, followed by the silver nitrate solution, 硝酸銀溶液. So first of all, you are going to add some dilute nitric acid to the sample solution. And later on, you're going to add a few drops of silver nitrate solution. And once you may see that the top here, we may find some white solid here. What we call it is white precipitate. White precipitate, something insoluble in water. So which means whenever I've got white solid here, which means chloride ions are present. So I would like to show you the chemical principle before, and before that, I would like to show you the steps again. You are going to dissolve the sample in distilled water. Second, you are going to add excess dilute nitric acid followed by the silver nitrate solution. Or if you don't want to use this one, or simply you are going to add, you may simply make this like this, a few drops of silver nitrate solution to the sample to be tested. And number 3, you are going to observe any appearance of a precipitate. If you have got appearance of white precipitate, suggest that the sample contains chloride ion. So this 3 steps, please memorize it. So white precipitate means it is not water soluble. It is water insoluble. So but for the other chemicals that mix together, it is still soluble. So that's why only this part is soluble, and it is a very good tool for you to know that this is chloride. We can find chloride inside that. So what is that white precipitate? That white precipitate, we call that silver chloride. And indeed, it's not that silver chloride will produce precipitate, but also other silver compounds, just like silver carbonate, silver sulfite, and they may interfere with the results. So that's why I would like to remember to acidify the silver nitrate solution. So the addition of the excess dilute nitric acid is to prevent the formation of other precipitate. It will confuse the result. We call it interfere with the results. So after adding the acid, those other possibility will be get rid of because those substances will dissolve in acid. So no worry, the most important thing is to acidify the silver nitrate solution if you are going to have the silver nitrate test. And what a coincidence is that similarly, you may have the compound made of a bromine and iodine, we call that bromides and iodide salts, can also be identified by using acidified silver nitrate solution. So you may find silver bromide and silver iodide, which is also water insoluble. But don't worry about that three precipitates because they will have three different color of the precipitate. For silver chloride, it is white. It is silver bromide, is pale yellow or creamy, while for silver iodide, this is yellow. So this is the formation, not only the formation of precipitate, but for color helps you to know which ions are found inside the sample. So I would like to recall your memory about what is the underlying principle is that we have got the sample of chloride ions, for example. If you talk about silver chloride solution, of course, we have got chloride, and then I add silver nitrate, and that is the silver ion into the silver nitrate solution that will merge with the chloride ion to form silver chloride, and leaving the other chemicals merged together, but that too, it is still water soluble. So this is what the underlying principle of the what we call it as precipitation reaction. So this is what we call the precipitation reaction. Precipitation, we call that 沉澱. So we will call that precipitate, we call that 沉澱物. Okay, so this is what we'd like to talk about this part. If you we have got sodium ion part tested, chloride ion part to be tested, and how about water? And this is what we would like to talk about in Form 2. You have known it in Form 2, yes. So we will use the paper to test for the presence of water. We call that dry cobalt chloride paper in Form 2, but for Form 3 or above, or if you study chemistry, we'll use the word dry cobalt 2 chloride paper. So the 2 here refers to the charge of cobalt, which is CO2+. So we will call that cobalt 2. And that when I apply the liquid onto the piece of dry cobalt 2 chloride paper, the paper will turn from blue to pink. Could you please remember the color? It is from blue to pink. So we will call that liquid contains water. Okay, so what is that? And also you may use anhydrous copper 2 sulfate to 水硫酸銅二. It is something a white powder, and I add a liquid into it. The white powder that will turn blue, and also is also a test possible for you to identify the presence of water. So remember, you may use either one method 1 or method 2. Okay. So maybe some of you may get confused about the color. So what is mean by blue, pink, or what? What is that? So if you want to recall your memory about the of the color changing of color related with water, I may give you this example. Silica gel. Silica gel, it is used as a desiccant. You may know what's that? It's a drying agent, which will help absorb water vapor in the air. So for those people who have got camera or some other materials, you have to make it dry. You may use this one. You may use that bracket, right? The pink bracket or the blue bracket. Of course, you use the blue one because if you only use the blue one, will they start to absorb water vapor? But use the pink one. Sorry, it has been used. So this is what we would like to talk about the cobalt to chloride. And indeed, why is it like that? We've got colorless silica gel as well. We have color silica as well. Why is it like that? Because that part, it is indeed mixed with cobalt 2 chloride. So can you get the point? So cobalt 2 chloride. So if you have got the blue silica gel, quite nice that it can be used to absorb water vapor. But once you have used it, so you may got it pink, which means that this silica gel will no longer absorb water vapor in it. So how will you treat this? Well, maybe some of you will just throw them away, but to me, I would like to keep it and put them into the oven. Do you know why? Because oven will apply heat, they will drive away the water, and the pink silica gel, they will turn back to blue, and you can reuse it. So this is what we will talk about, the uses of cobalt 2 chloride. It's not just the paper, but also I also blend it together with silica gel. So I just stop it here, and we'll go to the checkpoint. Checkpoint. Suggest a chemical test for each of the following substance, and so to suggest a test. So you still find that test for you to state expected observations in each test. So you are going to not only give you the name of the test, you need to give you step together with observations. So this is our proper procedure. So that's why water, 2 marks, of course, step and observations that you may see. How you get the presence of the water. First of all, first step 1, what is that? Drop a few drops of liquid onto a piece of, now remember the word, dry cobalt 2 chloride paper. So each term should be needed. You cannot skip any term. And 2, if the liquid turns the paper from blue to pink, the sample contains water. So you may see the word from blue to pink contains water. Now somebody will think that, Mr. Chin, is it a good test for you to show that the water is pure water? So which means that for some people who love to write down, it just must be water. The answer is no. Okay? So contains means that substances may have some other materials get blended to it. So that may be a mixture. For example, salt water. If I do that same test, it will also give you a color change. Okay? Or even you talk about maybe beer. For example, beer. If I apply to it, it will also change its color because beer contains water. So can you get my point? So this is what I would like to talk about. It contains water, but not, it will show it as pure water. How about sodium chloride? So solid sodium chloride. So remember the term solid. It's very, very tricky. Okay, so how you get that? So based on the 5 marks, you may find that Mr. Chin, that may be further split it into 2 parts. You are going to have a test for 2 parts, one for sodium part, one for chloride ion, such that you can score the 5 marks. First of all, for sodium part, you are going to use flame test. Carry a flame test. If the sample under strong heating gives a golden yellow flame, the sample contains sodium ions. So 2 marks, 1 mark for here, 1 mark for here. So remember, you are going to look for some terms. First of all, flame test. Second, golden yellow flame, sodium ions. So this is what I would like to look for. And for the chloride ion, you need to have the remaining 3 marks for that. How come we have got 3 marks? Now, could you see the word solid? And you deal with something about solid? Yep. Yes, you need to use silver nitrate test. But before that, you're going to dissolve the sample in distilled water. How come can we use distilled water? Can we use some other water? Tap water, sea water? Of course not. Tap water, sea water is not a good choice, because there may exist some impurities inside. And you may know that for seawater, of course, it's not, right? Because seawater contains sodium chloride. How about tap water? Tap water also contains chloride ion. Why? Because chlorine has been bubbled into the tap water for killing germs. So there may be some chances of getting chloride ions. So this is what you need to be considered. We will dissolve the sample into form a solution, but you use distilled water, the pure water. Second, you are going to add a few drops of acidified silver nitrate solution to the sample solution to be tested. So you are going to look for what? The observation, right? So if there is white precipitate, you need to memorize the term white precipitate. The sample contains chloride ions. So I would like to check for the keywords. First of all, you are going to dissolve in distilled water. Second, the few drops of acidified silver nitrate solution. And 3, you are going to check for the silver white precipitate, which tells you the presence of the chloride ions in the sample. So this is what I'd like to talk about 1B. How about question 2? Something more challenging, right? You try to have an integrated approach. We've got 2 unlabeled bottles, A and B. One of them contains sodium chloride solid, while the other contains sodium chloride solid. One of them potassium chloride, the other is sodium chloride. Suggest how you can distinguish between them. Distinguish. Distinguish what? These and these. Distinguish, which means 分辨 in Chinese, which means that it can help you know which is which. Okay, so we have got potassium chloride and sodium chloride solid. So you are going to use one test. So how we know that we use the test? Suggest how, right? Whenever you see suggest how, which means I need an experiment, please show me experimental steps together with the observation for both. Okay, remember. So this is our proper procedures of seeing that type of questions suggest how. So how will you get that? Potassium chloride, sodium chloride. Will we use silver nitrate solution? Well, both will give you observation, but both will give you white precipitate, right? So why? Because both contains chloride ion. So this is not the way to compare. I would not use chloride ion to compare. Instead, I use the metal part, potassium and sodium ion, to be distinguished. To use it for distinguishing which is which. Yes, that's right. You are going to do flame test. Yes, that's right. Flame test. Apply flame test on the 2 solid samples. So what will we? So this is what I would like to call the experimental steps, and we have got two observations. So what are the two observations? Yes, two different colors, right? So first one, if the sample gives a lilac flame, right? Another one is golden yellow flame. You may find that the conclusion is different, right? The first one, lilac flame, the sample contains potassium. Okay, the sample is potassium. So you may find the conclusion is that if the sample gives a lilac flame, the solar sample is potassium chloride. Can you get the logic, right? So the second one is golden yellow flame. It contains sodium salt. So of course, what is that? This is sodium chloride. So can you get my point? So this is what we are looking for. Take a look. I would like to take a look at the first flame test. Lilac flame, potassium chloride, golden yellow flame, sodium chloride. So this is what I would like you guys to try. That is the frequently asked questions in public in our assessment. Okay, so this is what we call it as puppy questions. Now, if not, you may take a look on this part. Electrolysis of seawater. What is it about? Well, for electrolysis of seawater, what is meant by that? Electrolysis is very, very strange method. What is that? So seawater can be further treated by chemical method to produce some more useful substances. So the chemical method we are going to talk about is electrolysis. Electrolysis, Chinese, 電解. So what is that? You split the word into two. Electro means electricity. Lysis means breaking down. So based on the Chinese words or maybe English words, you may know that, yes, you are going to break down something into simpler substances. So in case we are going to use electricity to pass through the process, we call it electrolysis. So one of a very authentic example is to electrolyze water into hydrogen gas and oxygen gas. I break down water, a compound, into elements. Okay, so what will happen if I have sodium chloride solution? The case is more complicated because for the sodium chloride solution, we have got 4 elements. We've got a sodium, chlorine, hydrogen, and oxygen. These two forms the salt, while these two forms water. So we are going to rearrange the constituent elements to form the useful substances. So here we go. So you may have got a electricity supply and connected to two electrode. One is anode, one is cathode. You don't know what's that, don't worry, you may cross them out. But that part you may know that the positive connected to red, the black it is negative. So this is what you may know in Form 2. And you're going to electrolyze sodium chloride solution, which is concentrated one, and try to see what will happen. So this is the experiment. So I would like to show you the experiment now.
We are back with a new video. Now in yesterday's experiment, I tried turning ocean water into hydrogen and chlorine gas, and it was a fail. And we found out that it's because I was using copper electrodes that it didn't work. The electrodes need to be carbon only, but I know this experiment can work and I don't want to give up yet, and sometimes the simplest method is the best. So today we're going to modify this setup a little bit and see if we can in fact extract chlorine gas from ocean water. So this thing right here is the modified system in a nutshell, and you're going to see it's very, very simple. All I did is heat up a screwdriver with a flame until it got hot enough that I could poke 2 holes in the bottom of this plastic container, just big enough for the carbon rods. Once the carbon rods were pushed most of the way in, I mixed up a batch of 5-minute epoxy, and I put a liberal amount inside and outside because we need this thing to be completely watertight when it's standing upright. We're going to keep the 2 holes that we made in the container from yesterday's experiment. Now all we have to do is fill this thing back up with more fresh seawater, attach some jumper cables to the bottom, and let it run. Okay guys, update, it's the moment of truth. I've been down to the ocean, I grabbed some fresh ocean water, I filled up the container, and I've hooked it up to my car battery. All that's left to do right now is attach the red jumper cable lead to the battery terminal and see if this thing actually works. All right, so here we go, moment of truth. Make the connection. Boom. Assuming everything's connected properly here, we should be generating chlorine gas off of the left side and hydrogen gas off of the right side. But there's not a whole lot of voltage or amperage, so we're just gonna have to let this thing hang out. And I'll probably start the car and let the alternator pick up some of the load.
Or to use the car battery as a power source, right? To electrolyze seawater.
After about an hour, and I hadn't noticed much gas production, and I think that's because the necks of the bottles were flat against the bottom, so there wasn't much way for electricity to flow through the solution. So I just used a couple of rocks and I propped these bottles up a little bit, and that allows the solution to conduct the electricity a little bit quicker. And since then, my rate of production on these gases have gone way up. And if we check this now, you can see that bottle is almost completely full of hydrogen. So now we got a full bottle
this is
of hydrogen.
hydrogen.
Slide it off.
You may find that a pop sound test, right?
So I built another contraption that will help us work with smaller quantities a little bit faster. This here is a much simpler setup. You can see I'm only running 1 carbon electrode through the side into a much smaller bottle. And that's because the limiting factor here is the amount of salt that's actually in our seawater. As the chlorine is extracted, it'll get collected into this bottle. So by using a smaller bottle, the concentration of chlorine that we end up should be higher. Smell this one over here and tell me what it smells like.
It smells like pool water.
Smell like pool water, like? Swimming pool water.
Hot tub.
A hot tub? It's been almost 3 hours now. And
well, can you see the color of the solution inside?
Displaced with the gas.
Oh, the gas?
Chlorine gas. And looking at it,
greenish yellow. It's no longer colorless.
So there's a good possibility that we actually do have chlorine. Boom! Finally! 4.5 hours of effort, but we finally got it. So here we have a little soda bottle filled with chlorine gas. Chlorine's awesome stuff because it can be used as a disinfectant for treating and sanitizing drinking water. But it is a very dangerous chemical. You don't want to breathe this stuff in. It could do some nasty damage to you.
Very nasty gas, right? Never smelled it like this way.
If you look inside there, you should be able to see a hazy yellowish brown cloud, and that appears to me to be chlorine. So I think we've done it. I don't have any use for chlorine.
I would like to skip a little bit.
Cool that we can make it if we need to.
And the people who are going to have the gas, and I would like to add
but if you pump a little electricity through it, you can make some pretty vicious chemicals.
They would like to add some water into the chlorine gas and try to see the bleaching effect of those gas. So try to see what will happen. Now, take a look.
I can taste that. That's bleach. I'm gonna go wash my mouth out. So I poured a little bit of
Never
water
tasted
into
like
this
this
bottle
way.
with chlorine and just shook it around for a couple of minutes to see if the chlorine will absorb into the water and form sodium hypochlorite or bleach. So I think what I'm gonna do now is pour the water out and figure out some way to test it. This is our homemade bleach using the water and chlorine.
Homemade bleach. Bleach, something which is used to whiten the clothes. So can you see that?
Oh my goodness, look at that. It's only been 1 minute and you can see already serious bleach stains.
Yeah,
wow, that's
to bleach the dye,
that is
whiten the dye.
insane. It's been 5 minutes, maybe 6.5. Yeah, you're not wearing that again. I'm super excited to say we did it, guys. We
yeah, so this is what I would like to stop it here. So this is what we would like to talk about the electrolysis, and some of the uses has been shown in the video as well. So what is that? Actually, we have got the red terminal, and you may see in the diagram as well. Here comes chlorine. It seems that the chlorine production rate is rather slow, when you compare with hydrogen. But indeed, they have got the same rate of production. Why is it like that? Why we still collect hydrogen faster? It's because hydrogen is water insoluble. It's a colorless gas, so you may collect it so fast. When you compare with chlorine, sorry, it is water soluble. Okay, so that water level will not be the same. But actually, the rate of formation of the two, they are the same. And it's something more than that. So you may have that example. So actually, what is that happening? We have got sodium chloride solution. It will undergo electrolysis to form hydrogen gas. Here on the right hand side, you may test it by the pop sound. When burned, so you may find that, right? And then chlorine gas, how will you know that? You smell like swimming pool. The greenish yellow gas, a very typical color of the gas. They will have a swim like swimming pool. They will have a bleaching effect. So we will call that a chlorine gas. And finally, it is sodium hydroxide solution. This solution will be changed to sodium hydroxide solution. Do you still remember you have heard of this term in Form 2? It is something alkaline. It is one of the commonly used alkaline in the IS lab, right? So this is what I would like to talk about. Wow, so nice that you have got the electrolysis product, hydrogen, chlorine gas, and sodium hydroxide solution. 3 substances, right? 3 substances. So what are the use of that 3 substances? Now, so you may find the hydrogen. It is commonly used as a rocket fuel, right? You know that the rocket, the pushing up of the rocket to the outer space, I use hydrogen. And what else? Hydrogen can also be used to make ammonia, a raw material, ammonia. So it is a that smell, while you go to the toilet, you can smell it, a very nasty smell. But the ammonia in the world is very useful because it is a very good starting materials to make fertilizers. 肥料, so which will help the plant grow. So what I need to do is to add hydrogen and nitrogen in a very specific condition to form ammonia. How about chlorine? Chlorine, you may know in Form 1 that it can kill germs in drinking water, or it can kill germs in swimming pool water. So that's why we call that a type of sterilizing agent. Sterilizing agent. So it is used to kill germs, to kill material into the water. So you may find it as this one. You're going to produce the PVC and some organic solvent. We have got this one. PVC, what's that? It is a type of plastic. Okay, PVC is a type of plastic. So how about sodium hydroxide? Sodium hydroxide is something alkaline. If I add some cooking oil, for example, you may produce soaps. Okay, you may produce soaps. The soaps is help you clean the dishes, to clean your body, etc. So this is what I would like to talk about. It's just that good natural raw materials produced by Electrolysis of Sea Water. It's not just that. You may also use the combination. You are going to react hydrogen and chlorine to form hydrochloric acid. You may react chlorine with sodium chloride hydroxide to form bleach as well. So hydrochloric acid is what I would like to mention with you. How about bleach? This one, during these days, you may know that you are going to use it to kill germs. And indeed, in the past, and we have got another application of using bleach is to whiten the clothes. It's not just be used as an disinfectant, right? But nowadays, you know that okay, bleach it can also help to kill germs. So So you may find that, wow, seawater is not just water and salt. And if you electrolyze it, you may further get some other useful raw materials for the good of the human. So this is what I would like to talk about, the electrolysis of seawater. Shall we take a look at the chat point? Finally, this is the last chapter before the end, the close of today's lecture. Sodium chloride is a major salt in seawater. It can be decomposed by electricity to form many useful products. The following experimental setup is used to decompose the seawater in the laboratory. So you may have guessed. Very similar, right? So name the above process. Name. So you may find you need to give your proper name. Electrolysis of sea water. B. Gas X is colorless and odorless. This one. Mr. Chin, you found that this diagram is just flipped 180 degrees. That is one. Can you see that? That this one is greenish yellow and this one is colorless. While for this one, quite the opposite, right? So, so you may be careful. Name as X. What is that? Gas X. It is hydrogen gas. How will you use a test to identify the gas X? Yes, that's right. So you have to got the point. Record your memory in form 2. Yes, that's right. So to put a burning splint into the sample gas, or the gas sampled, and if it gives a pop sound, the gas is hydrogen. And could you please suggest one use of gas X? Yes, that's right. To act as a rocket fuel, for example. You have to memorize one of the examples, right? I just memorized this one. And gas Y is greenish yellow in color and has a special odor, special smell. Name gas X. Gas Y this time it is chlorine. What is the smell of the gas Y? It's the smell of a swimming pool water. Or somebody who don't love to use that word. Wow, it's not so scientific, right? You may use the word pungent, choking gas. Okay, pungent, choking smell. So what is mean by pungent? Pungent, it means the nose will feel very, very bad feeling, and choking, you cannot breathe. Okay. You cannot breathe while you cough so very, very often. Pungent, choking smell. And give one use of gas Y. During this suspension period, of course, right, to make chlorine bleach, or you use to kill germs in drinking water. So do you think that you maybe because, or maybe after this video somebody will start think of can I DIY the apparatus? Well, to me, I would think of safety. So you may go into YouTube and you may find some safer method to produce this one. And you can also produce this. So be aware of the safety, be aware of handling the chemicals, especially chlorine and sodium hydroxide, the leftover solution, because it's alkaline. Chlorine is rather toxic. And most important is some hydrogen. Don't think that hydrogen is of no use. Hydrogen can be burned. So remember, you are going to reproduce that experiment in a well-ventilated area. So this is what I would like to remind you if you really want to try this at home. Now, part D. After experiment, the solution is set up becomes sodium hydroxide solution. Write the work equation to represent the decomposition of the seawater by electricity. So this is saturated sodium chloride solution and apply electricity. Okay, what will be the form? Hydrogen gas, recall your memory. Chlorine gas it can be used to make bleach, and finally something alkaline, we call that sodium hydroxide, HYDROXIDE solution. So this is something alkaline. So what is the use of sodium hydroxide? To do what? For example, to make chlorine bleach, I need sodium hydroxide. Yes, that's right. To make soap. Yes, that's right. To make chlorine bleach. Or even for somebody who know that this is alkaline, it will help dissolve the oil. It may be used as a drainage cleaner. Okay, drainage cleaner, the wastewater, the wastewater pipe has been clogged, so you may add this to clear away those oil, especially used in kitchen. So this is what I would like to share with you about electrolysis of seawater. So that's the end of today's online tutorial, and if you have any more questions about this chapter, maybe let's talk about it while you are having the online lecture. See you guys.